Chapter 5, Input. An input device is a piece of hardware that moves data, control, information into the computer. Some of the common input devices are a keyboard, a mouse, a touch screen, touchpad, scanner, digital camera, and joystick. A computer keyboard is a typewriter-style device, uses buttons or keys acting as switches. The keyboard is the most common input device for direct input of alphanumeric data into the computers. The keyboard is used for text entry, to type text and numbers into the word processor, text editor, or programs. Keyboards are also used for gaming, either with regular keyboards or with special gaming keyboards. Before the development of GUIs, the common way for users to interact with their computers was by means of the keyboard using command line interface. Computer keyboards have different sizes and different key spacings, as well as different forms and displays. The standard computer keyboard includes alphanumeric characters, punctuation symbols, numbers, and several function keys. There's no real standard keyboard for computers, but many manufacturers imitate the PC keyboard. Keyboards on laptops and notebooks generally have a shorter travel distance for the keystroke because the computers are thinner. They have to have can't move as far. They also have a shorter distance between the keys. The keys are closer together because they're smaller, and they have a reduced set. They don't have all the keys that a full-size computer would have. Many of them don't have a numerical keypad. The function keys will be in different locations than they will be on the standard full-size keyboard. Flexible keyboards are kind of a combination between normal and laptop. They have the full size, so they have the full arrangement of all the keys, but they're thinner, and so they don't have the same keystroke different distance to enter. Of course, being flexible, the user can fold them up or roll them up, making them easier to store and transport. The vast majority of flexible keyboards are made out of silicone, and because of that, they're waterproof and dustproof. This is particularly convenient in places like hospitals where the keyboards get washed a lot. The flexible keyboards very often are connected using a USB cable, but some of them use Bluetooth for communication. Cell phones with touchscreens will usually use on screen keyboards, probably because the hardware keyboards are more expensive and larger, take up more space, so that the cell phones would end using hardware keyboards would be larger and more expensive. Virtual keyboards, on screen keyboards, also provide flexibility. They can display a new keyboard whenever the user wants to switch to a new language. The user can type directly in a local language script in an easy and consistent manner. No matter where you are or what kind of computer you are using, the on screen keyboard controlled by software can be can use the local script. Some common uses of virtual keyboards include allowing the person to type in their own language on foreign keyboards, such as when traveling abroad or living in another country. The foreign can use your home language even on the foreign computer if it uses an on screen keyboard. It enables a more accessible typing experience by allowing typing by on screen clicks, and provides a fast, simple way to switch between different character sets or alphabets. Projection keyboards project an image of a keyboard onto a flat surface and uses a sensor to detect position of the user's fingers. The projection keyboard can simulate a full-size keyboard even with a very small projector. Of course, requires a flat, non-reflective surface that allows the images of the keys to be displayed. Most projection keyboards are made for use with PDAs and smartphones because the sizes of these devices don't support large, full-size physical or on-screen keyboards. There are a lot of different arrangements for the alphabetic, numeric, and punctuation symbols for the keys. The main reason that there are different keyboard layouts is that different people want easier access to different symbols. Some because they're entering text in different languages. Some need a specialized layout for things like mathematics or accounting or programming or other specific purposes. The United States keyboard layout is used for the default in the most popular operating systems, Windows, Mac OS, and Linux. The common QWERTY-based key layout was designed early in the era of mechanical typewriters and was designed to compensate for mechanical limitations in the way that the typewriters were built. QWERTY layouts were adopted for electronic keyboards because they were widely used. Most of the people using keyboards were already familiar with the layout and were trained to use them. Alternative keyboard layouts exist, like, for example, the Dvorak simplified keyboard, but they're not in really widespread use. The Dvorak simplified keyboard is a keyboard layout patented in 1936 by August Dvorak and his brother-in-law, Dr. William Dealey. The Dvorak proponents claim that this layout requires less finger movement and reduces errors compared to the standard layout, the QWERTY keyboard. It's claimed that the reduction in finger distance movement permits faster typing and reduces injuries due to repetitive movements. The Quartz Z layout is widely used in Germany and much of West Central Europe. There are keyboards designed for typing in Spanish that have characters moved to create space for the letters ñ. Keyboards designed for use by Portuguese, French, and other European languages have a special key for the C cedilla characters. The AZERTY layout is used in France, Belgium, and some neighboring countries. Keyboards in many parts of Asia have special keys to switch between the Latin character set and completely different character typing system. In the Arab world, keyboards can often be switched between Arabic and Latin characters. In bilingual regions of Canada and in the French-speaking province of Quebec, keyboards can often be switched between English and French language keyboards. Using keyboards for more than one language leads to a conflict. The image on the key doesn't necessarily correspond to the character produced on the screen. In such cases, each new language may require an additional label on the keys because the standard keyboard layouts don't share even similar characters from the different languages. An image scanner, or just a scanner, is a device that optically scans images and creates digital representations of them. There are several different kinds of scanners. Some of them are flatbed scanners, handheld scanners, 3D scanners, document scanners. Color scanners typically read RGB, red, green, blue color data. Color depth for color scanners is the number of bits used to represent a color, and it varies depending on the scanner, usually at least 24 bits. The high quality models have 36 to 48 bits color depth. Another parameter commonly used for describing capabilities of scanners is resolution. Resolution is measured in pixels per inch, PPI, pixels per inch. As of 2009, a high-end flatbed scanner could scan up to 5,400 pixels per inch, and drum scanners had an optical resolution of 3,000 to 24,000 pixels per inch. As of 2020, there were several scanners on the market advertising 6,400 dots per inch and 48-bit color depth. A document scanner is a scanner designed specifically to process collections of loose leaf papers, usually just interested in representation of text. These scanners are generally going to have document feeders. Many all-purpose copiers and all-purpose scanners will also have document feeders, but the document scanners will have larger, better document feeders. The main purpose of the document scanner is to capture images of scanned documents or text and save these images digitally to either picture or PDF format. Scanning technology has advanced, and most document scanners can distinguish between variations in color. Those with built-in optical character recognition software, OCR software, are able to convert images to editable text. OCR, optical character recognition, is the conversion of images, pictures of typed, handwritten, or printed text into machine-encoded text. It's widely used as a form of information entry from printed paper data records or any suitable documentation. It's a common method for digitizing printed text so that they can be electronically edited, searched, stored, more compactly displayed online, and used in machine processes. Document scanners typically run at high speed, 20 to 150 pages per minute. They're usually done in grayscale, although this document scanners, many of them, do support color. Many document scanners are capable of duplex operation. They'll scan both sides of the papers. Sophisticated document scanners have firmware or software that can clean up the scans of text as they're produced, eliminating marks and sharpening up the text. Files created can be compressed as they're made. The resolution used by a document scanner is usually from 150 to 300 dots per inch. The hardware may be capable of higher resolution, usually is capable of higher resolution, but 150 to 300 dots per inch produces images good enough for text to be read. It provides adequate clarity for optical character recognition. Higher resolution would result in slower scan times and would require more storage space. A pointing device is an input interface that allows the user to input spatial data to the computer by controlling the position of a cursor on the computer display. The most common pointing device by far is the mouse, but many more devices have been developed. Sometimes the word mouse is used as a generic term for a pointing device, for a device that moves a cursor, which gives you an idea how dominant the use of the mouse is as a pointing device. A computer mouse is a pointing device. It controls the movement of the cursor on the display screen. The mouse was invented by Douglas Engelbart of Stanford Research Center in 1963. It was pioneered by Xerox in the 70s, and the mouse is one of the great breakthroughs in computer user interaction. Physically, it's an object that can be held in the user's hand. Normally, it'll have one or two buttons, often three buttons, a third button or a wheel that enables the wider range of input and additional control over a graphic user interface. The mouse is important for graphical user interfaces because you can simply point to options and objects and click a mouse button. Applications that use this are called point and click programs. There are three basic kinds of mouse: the mechanical, optomechanical, and optical. The mechanical mouse has a ball, rubber or metal ball on the bottom side, and as you move the mouse, the ball turns, and mechanical sensors inside the mouse detect the direction that the ball is rolling, and it moves the screen pointer accordingly to how the mouse moves. Optomechanical is basically the same thing. It has a ball on the bottom, but the mouse uses optical sensors to detect how the ball is moving rather than mechanical sensors. Optical mouse uses a laser to detect the mouse's movement. There are no mechanical moving parts. A trackball, a different kind of pointing device. It's a pointing device with a ball held in a socket containing sensors to detect how the ball moves. It's like a mouse turned upside down, and you can move the ball with one's fingers rather than sliding it on a surface. The user rolls the ball with the thumb and fingers or the palm of the hand, and as the ball moves, it controls the position of the pointer. A trackball has some important advantages over a mouse. There are times when your mouse reaches the edge of the working area and the user wants to keep moving the pointer further. With a trackball, the operator just keeps rolling the ball. The mouse has to be lifted and repositioned. Because trackballs are stationary, they require less space for operating than does a mouse. And that makes them easier to use in confined or cluttered areas. That for this reason, they are often preferred for use in laboratory settings. Many people with mobility impairments use trackballs as input devices in assistive technology. Trackball users often appreciate the fact they're not limited to using the device on a flat surface. Trackballs can be used while browsing on a laptop while the user is in bed or sitting in an armchair. Trackballs are also useful for computers using on boats or other unstable platforms where unexpected movement could produce unintended input. Another kind of pointing device is a joystick. It works pretty much like a mouse, except that with a mouse, you stop moving the mouse and the cursor stops moving. With a joystick, the pointer just keeps moving as long as the joystick is pointing. To stop the pointer, you have to return the joystick to the upright position. Joysticks also include buttons called triggers. They are commonly used for computer games, but you also see them in CAD/CAM systems as well as other applications, using for controlling machines like cranes, trucks, underwater unmanned vehicles, wheelchairs, surveillance cameras, even lawnmowers. A touch screen is a computer display screen that is also an input device sensitive to touch. The screens are sensitive to pressure. A user can interact with the computer by touching pictures or links, words on the screen. There are three kinds of touchscreen technology: resistive, surface wave, capacitive. Resistive touchscreen is the screen is coated with a thin metallic conductive resistive layer that causes a change in electrical current. when the user presses on it. Surface wave uses ultrasonic waves that pass over the touchscreen. When the panel is touched, a portion of the wave gets absorbed. Capacitive screens are coated with a material that stores electrical charges. When the panel is touched, a small amount of charge is drawn to that point of contact. A graphics tablet consists of a flat surface where the user can draw or trace an image with an attached stylus. The image is usually displayed on the computer monitor, although some graphic tablets incorporate LCD screens for a more realistic or natural experience. Touchpad or trackpad is a device that has a specialized surface that can sense the position or movement of a user's fingers. They are a common feature on laptop computers and can also be used as a substitute for a mouse in situations where desk space is limited. A gamepad is a type of input device held in two hands and allows the fingers, and especially the thumbs, to be used on the control unit. They're typically the main input device for video game consoles. They can also be used with personal computers. They usually feature a set of buttons handled with the right thumb and a direction controller handled with the left. The direction controller traditionally is a four-way digital cross. Many modern computers also feature one or more analog sticks. From the very first, workers have dreamed about being able to control computers with spoken commands. But until quite recently, this was just an aspiration, a dream. Recently, however, speech recognition has developed to the point where it can be used effectively, and its applications are becoming quite widespread, especially in business call centers. Computers and mobile devices now commonly come with speech recognition software installed. Speech recognition technology still has a few issues, and it's still in the process of development. The pros of speech recognition software are it's easy to use and readily available. People can talk faster than they can type, so verbal text entry is more efficient and faster than keyboard entry. It still has a few problems capturing words due to variations in pronunciation, in difficulty in interpreting accents, and inability to sort through background noise. These factors can lead to errors. All right, voice recognition systems and perform at or even above the level of normal humans. But there are applications for which that is still just not good enough. From a technology perspective, speech recognition has a long history with several waves of major innovations. Most recently, they've been applying advances in deep learning and big data. The advances are evidenced by worldwide industry adoption and deployment of a variety of speech recognition systems. These speech industry players include Google, Microsoft, IBM, Baidu, Apple, Amazon, Nuance, SoundHound, and iFlyTech. Much of the progress in the field is due to the increased capabilities of more recent computers. By the end of a major DARPA program in 1976, the best computer system that was available to researchers in speech recognition was a PDP-10 with 4 megabytes of RAM. One of these computers would take up to 100 minutes to decode just 30 seconds of speech. A few decades later, researchers had access to tens of thousands of times as much computing power. As the technology advanced, computers got faster and storage got bigger. Researchers were able to tackle harder problems, larger vocabulary, speaker independence, noisy environments, conversational speech. The 1990s saw the first commercially successful speech recognition technologies. Two of the earliest of these products were Dragon Dictate and a recognizer from Kurzweil Applied Intelligence. Dragon Dictate was released in 1990, and Kurzweil Intelligence released their in recognizer in 1987. AT&T deployed a voice recognition call processing service in 1992. They used it to route telephone calls, replacing human operators. The technology that AT&T used was developed at Bell Labs, and at that point, 1992, the vocabulary for a typical commercial speech recognition system was larger than the average human. In the United States, the National Security Agency has made use of a type of speech recognition for keyword spotting. They've been doing this since at least 2006. NSA is not noted for giving out information easily. The technology they use allows analysts to search through large volumes of recorded conversations and isolate those that have specifically used certain keywords. Neural networks have been used in many aspects of speech recognition, aspects such as phoneme classification, isolating word recognition, audio-visual speech recognition, audio-visual speaker recognition, and speaker adaptation. Speech recognition is now widely used in automobiles, where you can initiate phone calls with simple voice commands, select radio stations, play music from a smartphone, MP3 player, or from music loaded in a flash drive. And speech recognition is used in medical documentation. In medical documentation, it can be implemented as a front end or back end of the documentation process. Front end, speech recognition, the provider dictates into the speech recognition machine, and the words that that are recognized get displayed as they're spoken. And the guy who's talking is responsible for editing, catching any errors, and signing off when he's done talking. With a back end or deferred speech recognition, the provider dictates into the system, and the voice gets routed through the speech recognition machine, and the recognized draft document is routed along with the original voice file to an editor who checks the draft and corrects any mistakes before producing the final version, the final report. Deferred speech recognition is much more widely used than front-end recognition. In telephony, speech recognition is common, and it's becoming more and more widespread in computer gaming and simulation. Speech recognition in education can be very useful for learning second languages. It can teach proper pronunciation and help develop fluency and speaking skills. There are several voice recognitions in wide use. Some of these: Amazon Alexa, Microsoft Cortana, Apple Siri, and Nuance Dragon. Alexa is an artificial intelligence powered by Amazon's cloud computing infrastructure. Alexa adapts to the user's voice over time, which tends to offset the issues with accents or dialects. The system Alexa learns to interpret the user, understand the user's accent or dialect. Alexa can do quite a bit, the initial version, out of the box, but its capabilities can be expanded by enabling what are called Alexa skills. The skills can be thought of as Alexa's version of apps. You download and install the skill that you want it to have. Some skills are created by Amazon and affiliated partners, but the vast majority are third-party creations. Independent developers and large companies alike have published skills for Alexa to help do things. Do things like ordering a pizza from Domino's, calling up an Uber, or playing games. Cortana is a virtual assistant developed by Microsoft. It was released in 2015. Cortana can perform tasks like setting reminders and answering questions for the user. Cortana uses the Bing search engine to find answers. Microsoft announced the availability of Cortana for Windows 10 desktops and for mobile devices in January 2015. They also announced that Cortana would be available on other mobile platforms. An Android version of Cortana and an iOS version were released in December of 2015. Apple Siri came out in 2011. Siri was the first voice assistant that was created by a mainstream tech company. Siri has been integrated on all iPhones, iPads, Apple Watch, HomePod, Mac computers, and Apple TV. In 1997, earlier than these others, Dragon Systems released a product named Naturally Speaking One as a continuous dictation product. This software has three primary areas of functionality: voice recognition and dictation, with speech transcribed as written text, recognition of spoken commands, text to speech, speaking text content of a document. Later, the rights to the Dragon product line were acquired by Scansoft, and then in 2005, Scansoft acquired Nuance Communications and rebranded itself as Nuance.